In this video, we are going to explore one of the basic structure of programming. They are called functions. Functions are a group of related statements to perform a specific task. The keyword is specific task. So functions have specific purpose and you will create them in order to achieve something. Functions are very useful to make your code reusable. We can define a function with related statements, and whenever we want to execute those statements, we can simply call these functions. Calling a function means executing the statements we had written inside the function. The basic structure of function looks like this. We can define a function using def keyword. This is a keyword in Python programming language. After that, we can write any function name. The function name follows the same naming rules as variable names. So we can have functions starting with underscores or any alphabetic characters. But we cannot have functions that starts with a special character or a number. Now functions sometimes take parameters. We will learn about parameters later in this video, but they are simply some arguments that allow us to customize the behavior of the function. Don't worry if you don't understand this, because it will become clear when you see a real life example. After that, we write this colon and it creates a block. Inside this block, we can write the statements that we want to execute when we call this function. Functions can sometimes return a value. That means that function will do some calculation and finally return the calculated value to the line where the function was called. We can also write Docstring inside a function. This is the documentation for a specific function. This helps other Python developers when they are using your function. I would highly recommend that you write docstring for any of your functions. Docstrings are written using triple quotes. We can view these docstrings in Python itself using help function. We will see that in this notebook. Now let's see a practical example of a function. Here I have defined this greet function. I have used this def keyword. Then I have named my function as greet. After that, I have this empty parenthesis. I'm not taking any parameters, so that's why it's empty, but you still need empty parenthesis. Inside the function body, I'm simply printing hello. Now, in order to execute or call this function, we just have to write the function name and a pair of parentheses. So when I run greet, it will simply execute all the statements inside this function. So it simply prints hello. When I write something like this, function name and a pair of parentheses, that's called invoking a function, executing a function, or calling a function. These three terms mean the same thing. Functions are reusable. That means whenever I want to print hello, I can simply call this function. So if I call this function multiple times, it will print hello that many times. Let's say I want to define a function to greet a specific person. In that case, I can write something like this. So the only difference in this code is that it's printing hello for John. If I want to customize this function so that it can greet anyone, not only John, then in that case I can use the parameters. If you remember, we can pass the parameters inside this parentheses. So here I'm writing name. This is a kind of variable which will be local to this function. Inside the function body, I'm simply printing hello plus name. When calling this function, I can write any name inside this pair of parentheses, and that name will be assigned to this name variable. So if I run greet John, it will print hello John. But now I can use this same function to greet any other person. So if I write greet Peter and greet Bob, then in that case it prints hello Peter and hello Bob. This makes our function reusable for different people. We don't have to write the same statement for different names. We can simply invoke this function and pass different name into it. We can also write docstrings like this. Docstrings usually contain the information about the purpose of the function. So here, for our greet function, I have written this docstring which says prints greeting message for a person. And this method is taking one argument which I have mentioned here. So that way, this docstring may be helpful for someone else who is going to use our function. We can check this docstring inside the Jupyter notebook by using the built-in function help. Help greet, and here you can see that it prints a docstring. We can also see the docstring using function name dot underscore underscore doc underscore underscore attribute. These double underscores are called dunder in Python community. So you can also call it greet dunder doc. So I'm printing this double underscore doc attribute, and it prints the docstring we had written in our function. Now, as I mentioned earlier, functions can also return a value. When we are executing a function, if we cannot return any value, then the only thing we can use the function for is to print something on the screen. But that's very limiting. Functions are also used to simplify our code. So for example, when we have large piece of code and we want to separate them into small chunks, then we can write separate functions for that. In that case, it may be helpful if the function could return some value and those values could be assigned to another variable. Let me show a practical example of this. In this piece of code, I have this add function, and I'm creating this num1 and num2 variable outside the function body. When I print add num1 num2, then it prints 5, but it also prints this none. It can print this number 5 as we expect, but what is this none? Python by default returns a none value when we don't have an explicit return statement. It is a special keyword in Python, and it simply means the absence of any value. It means it is not returning anything. If we write a return statement instead of printing this addition, then in that case, whenever we'll call this function, that call will be replaced by the return value. So this add num1 num2 will be replaced by num1 plus num2. Another major difference that I wanted you to notice is that my variable name can be different from the parameter name. So here the num1 value will go inside this a variable and num2 value will go inside this b variable. So ultimately it is going to return num1 plus num2. But inside the method body, those variables are called a and b. If I print add num1 num2, this simply prints the summation of num1 and num2, the return value of this function. Now because this function call will be replaced by the return value, we can assign a value by calling a function. So here in this piece of code, I have this sum variable, and this variable is getting assigned in this statement. So I can write something like this: sum equals add num1 num2. This add num1 num2 will be replaced by 2 plus 3, 5. So sum will have the value 5. And here I print this, and you can see that it has the value 5. Similarly, if we are returning multiple values from a function, we can assign it to multiple variables. In this case, I have this function sum and product, which returns sum and product of two numbers. So it calculates sum, product, and finally in the return statement, it returns both those values. We can assign both these values to different variables like this. So here num1 will have the value of sum of 2 and 3, and num2 will have the value of multiplication of these two numbers. If I print those two values, you can see it has 5 and 6. It's important to understand how exactly the function call executes. In this very simple code, I have this print statement, then I have this assignment, and after that I have another print statement. The program flows from top to bottom. So first the function is defined, but it won't print anything because we are not actually calling this function. The first print statement will be this one because this is the first print statement it encounters from the top. After that, we have this value equals sample function. In order to assign a value to this variable, we first need to evaluate the right hand side. It will call this function. Control flows inside this function, and in the first statement it will print inside the function. After that, it's returning 1, which will replace this function call, and this variable will have the value of 1. After that, we are printing this statement, and at the end we are printing the value of the variable, and that's how we get these statements printed here. Now let's look at a little bit larger piece of code. Here I have created a very simple calculator. In order to create a calculator, we need basic operations like addition, subtraction, multiplication, and division. For all of those, I have defined these 4 functions. So add function simply returns the addition of two numbers, subtract returns the subtraction of two numbers. Similarly, I have defined multiply and divide functions. Here I have written some instructions for the user of this simple calculator. We can write add command and it will be used for addition of two numbers, sub command for subtraction, mul command for multiplication, and div command for division. In order to perform any of these operations, we need two operands. These are two numbers that can be added or multiplied. So for that, I have defined this sample utility function, collect numbers. It simply collects a number from the user and casts it into integer data type. And finally, I return those two numbers. This is where the actual logic is implemented. I have this outer while loop which will keep running, and here I am collecting the operation user wants to perform. So user can enter add, sub, mul or div operation in order to perform addition, subtraction, multiplication or division. Here I have this if-else block which checks which operation the user wants to perform. If the operation is addition, then I take two numbers using collectNumbers function. Then I add those two numbers using add function call. And finally, I'm just printing the addition of two numbers. The same logic has been implemented for subtraction, multiplication, and division. If the user enters quit, then I want to exit the loop. So here I'm just printing thank you for using this calculator, and I'm using break statement to exit the loop. If user enters any other input, then it prints invalid input and suggests them to use one of these 5 options. So let's execute this. If I write add operation and I enter two numbers as 1 and 2, then it prints the addition of two numbers as 3. Let's check subtraction, 2 and 3, and I get back -1. If I enter quit, then the calculator application exits. This is a very simple demonstration how we can break down our large code base into smaller manageable functions. Now let's understand variable scopes in Python. Whatever variables we define, they have specific variable scope and lifetimes. That means those variables are only available only for the duration of specific block of code. Outside that block, those variables may not exist. Python automatically removes the unnecessary variables and references when we no longer need them. This process is also called garbage collection. We have global variables, which are variables defined outside the function body, and they are available anywhere in the code. All the variables defined inside the function body are called local variables. So for example, I have this sample function, and inside the function I'm defining this variable name. I can use that variable inside the function. So if I execute this function, it will simply print this name Jessica. But if I try to use this variable outside the function body, like here, and if I run this, then you can see that it throws name error. Name is not defined. So it doesn't have any idea about this name variable we had defined inside the function body. These are called the local variables. Local variables are not available outside the function body. Similarly, in this piece of code, I have this name variable Andrew, and I have defined this outside the function body. Now inside the function, I have also defined the same variable name with another value. So when I call this function, this print statement simply prints the local variable. So local variables shadow the global variable. When the execution of this function ends, this local variable no longer exists, and outside the function body, when we print this name variable, it will print this global variable. So here it prints Andrew. We can also access global variables inside the function. In this case, I have defined only the global variable, and I have not overridden that variable inside the function body. So when I print name variable inside the function body, if that function doesn't have name variable, then Python automatically looks up in the global variable namespace, and it will look for name variable in the global namespace. Here it finds this name variable in the global scope, so it simply uses that variable. Outside the function body, as usual, we can use the global variable. In Python, there is a special keyword global which allows access to global variables inside the function body. So inside the function body, if I write global name, then this name variable refers to this global variable. Now if I modify this name variable inside the function body, and now if I call this function, you can see that it has actually modified the global variable. Usually when we modify a variable inside the function body, that variable doesn't affect the global variable, but because we have used this global keyword, it actually modifies this outer variable. Now this is not a standard practice in Python, but I just wanted to introduce this problem. So when you come across this kind of problem, you should be able to figure out the root cause for that. Modifying global variables inside the function body is a very bad practice and you should not use that. It can result in difficult to find bugs. Bugs are also the coding errors developers create. Unlike other programming languages, Python doesn't have block level scope. In languages like C, C++, Java, we have block level scope. So if we define any variable inside the if block or while loop, those variables cannot be used outside that if block. But in Python, that's not the case. For example, in this simple function, I have defined this if block, and inside that I have this result variable. But even outside this if block, I can use the same variable. Similarly, for while loop or for loop, if I define a variable inside that block, I can still access that variable outside the block. So that's little bit different from other programming languages. In other programming languages like Java or C, if you try to do this, it will result in compilation error. In Python, we can also provide default values to variable names. So when we are defining a function, we can also specify default values like this. The benefit of these default values is that now we can call this function in multiple ways. So if I pass a name, then this name variable will be assigned this value. But if I call without passing any argument into it, then by default this name variable will have the default value. So now it prints hello buddy. When using the default arguments, we have to make sure that the default value parameters are specified at the end of the argument list. To give you an example, here I have defined this default argument before the non-default argument. This name variable doesn't have a default value. If I try to execute this code cell, it returns syntax error. And the problem is that the non-default argument follows default argument. If I change the sequence and define the name variable before the greeting variable, then everything runs fine. So the default value arguments must be specified after the non-default arguments. In Python, we can also use keyword arguments. This can be very helpful if we want to specify the arguments in any order. For example, here I have defined this welcome function with two variables greeting and name. Both of them have default values. So I can call this function like this. What happens if I don't specify the greeting value? but only specify the name variable. In that case, by default, this first value will be assigned to the first variable. So this name variable is by mistake assigned to the greeting variable. This results in a wrong output. In order to avoid that, we can use keyword arguments. Keyword arguments are specified using the keyword and the value we want to assign. If I specify greeting equals welcome and name equals Thomas, then those will be assigned to respective variable names inside the function. Now, if I only specify the name, then I can write name equals Thomas, and it will match this name with the name of the parameter. Thomas will be assigned to the name variable, and now it prints the exact output we were expecting. So this way, keyword arguments can be helpful when we don't want to specify arguments in specific order. Now there are a few extra features we can use when defining a function, but we will learn about those in upcoming videos.